Sorry, I'm here with Jose, who's the winner of the DOXA Matching Challenge. So, Jose, first of all, congratulations. Jose has won £500 in vouchers for training the highest performing large language model on the Harmony DOXA Challenge. So, Jose, first of all, would you like to introduce yourself? Let us know a little bit about your day job, what you do, how you found the challenge, and everything. It would be great to hear a little bit about that.
Yeah, so hi, I'm Jose Inés Martínez. You can call me Jose. I'm a fourth year undergraduate student at the University of Illinois Urbana-Champaign studying computer science.
Perfect. So yeah, my name is Rafi, and I have recently graduated from City University as my master's in artificial intelligence, and I have experience of around 1.5 year in this field of AI and machine learning, and that's all about it as of now.
Thanks,
Yeah.
Rafi. Jeremy, do you want to introduce yourself as well?
Sure thing. So, hi, I'm Jeremy. I'm the co-founder of DOXA AI. I help organizations host AI competitions and things of that sort. And I'm also the lead organizer for Climate Hack AI.
I found this challenge because I had been familiar with the DOXA platform beforehand because I had previously tried to compete in Climate Hack. And so during the break, I kind of wanted to do something. And I found the DOXA challenge, and it looked pretty interesting, like the matching challenge, right? And I decided to tackle it over, I think, a week or two. And I got some pretty good results. Yeah.
Great, thanks, Jose. So how did you find combining this kind of thing with having a day job? Or so you're an undergraduate right now, and do you have a day job as well, or how did that work?
Not right now.
Just okay. So how did you find combining it with your studies? Was it a struggle to find time?
Well, I think during the time where I actually did participate in the competition, it was around I think late December to early January. So I
Okay.
mostly invested my time during that free time that I actually have.
Okay.
So I didn't really have to like make it kind of work in between like my schedules
Okay.
for the classroom.
So do you have any experience fine-tuning large language models? Is this something you've done before?
Yes, it's something that I have done before previously in a research project that I had to undertake for a graduate class that I took. The graduate class was in, I think, advanced topics in machine learning, security, privacy, and systems. But the project we had specifically developed was for detecting and mitigating large language model jailbreaking prompts. So, you'll throw out a jailbreaking prompt, and you should be able to kind of train a model or have some kind of heuristic that can actually pick up on whether it's actually some kind of jailbreaking prompt. And we had several different kind of like methods for this, and between one of those methods was actually fine-tuning I think a distilled model, right? To actually be able to kind of pick up on whether it would actually be considered as like a harmful or like a toxic sentence. So I kind of got a little bit of interest from actually fine-tuning that specific, like, I think it was just a transformer model. So I got experience from actually just like fine-tuning on that transformer model from the beginning. So I kind of somehow knew how to approach this, but it would be a little bit different because this is a sentence transformer. This wasn't a normal transformer.
Okay, that's cool. And so how did you choose the base model?
So the base model, I saw the template, right, that was already set up in the website.
Yep.
And the original kind of like model that was already set up was, I think it was all MPNet base v2. That's a sentence transformer. I think it's on Hugging Face. And I was mainly looking for models or sentence transformers that had already been like trained to actually do some kind of like semanticity meaning, or like semanticity kind of like meaning, how would you call it, like search, right? Because I say in here that it's meant for semantic search. So my hypothesis was, well, if I use like a model that's already meant to be used for semantic search, then I can actually use it to actually kind of like transfer it over to this competition. And it was already set up in the template. So I decided to kind of run along with that one. And that was actually the only model I ended up using. Rafi will arrive kind of shortly later on, And he was, I was talking about it with him,
Yeah.
and he actually decided to test a bunch of different models, something that I didn't do. And, after talking to him about it, I actually found very insightful because he tested a lot of models that I think would have been actually better performing if I had actually done the optimizations that I had done in this model, but perform it to a bunch of other models and hopefully see if we actually have any performance improvement. But I think all
that
of
would be interesting to find out.
all of these performance improvements at some point would have been very narrow. So we wouldn't have able to see a lot of kind of improvement other than because I think the barrier for all of us that were actually in the competition was getting to sub 20 mean absolute, right? Which was kind of impossible because at some point it was just kind of random whether you would actually go up or go down of 2.50 around something like that, right? And so I ended up using all MPNet based V2. And what I ended up doing was, well, I'm going to grab this training data set that you provided from the psychologist having labeled both sentences and giving a human similarity score, right? And I'm going to use the quotient similarity loss that was already also set up in the template, right? But the only difference that I actually ended up doing was that the quotient similarity loss function by default actually uses the mean squared error. Right. So I just kind of had to switch it from a mean squared error which is L2 loss to an L1 loss, which is the mean absolute error.
Oh, I see. Yeah, that's perhaps an artifact of how we chose to evaluate. I mean, because we could just as easily have set the criteria for winning the challenge as being MSC instead of MAE. And I don't know if we had an absolute reason for choosing that. The other thing is when the psychologists write papers about which model best predicts something, we tend to use R squared, which is yet another metric, which, I don't know if there's a loss function that would optimize for that.
Yeah, because I was also curious because I did see that the main kind of metric that was being utilized was actually the mean absolute error.
Yeah.
But on the side, you could see that you also had an R squared. And I was kind of confused on what it actually meant. And I'm still kind of confused. So I would like if you guys could elaborate on it. Because sometimes fluctuate vastly. Because sometimes some very good performing models on my validation data set would actually get 0.60. But then, when you transfer them over, then it's 0.11. Or another one would actually score pretty nicely on the mean absolute error, but I would actually have minus 0.11 R squared. So, yeah.
I think, it's, I also noticed a model can perform very well on MSE or MAE and perform badly on R squared and vice versa. And I mean, the R squared is, I can't remember if it's called the Pearson or the Spearman correlation coefficient, one of those. And it just comes out of statistical packages like R, but we don't tend to use it so much in machine learning, and I'm not quite sure why. I guess it's not such a good measure when you're trying to predict something. I don't think it's the best measure of does this thing that comes out of my algorithm predict this thing that, correlation between how people respond to a questionnaire. But it does kind of give this robust statistical value because with the R squared, that's how you can say our model predicts people's responses to this questionnaire with p-value less than 0.05. So that's kind of what it is used for. I mean, Jeremy, have you got any more?
Because it's linked to the variance of the residuals, which is kind of why the models that did well on the MSC front also did well on the R squared front.
Yeah,
but not perfectly. R squared, though, can be a little bit strange when you're using that directly as a metric, just because sometimes you get some weird issues with scaling at time, which can happen. If let's say your model could explain, say, it gets R squared of 0.2 or something, explains roughly 20% of the variance in your target. You can get some strangeness on that front.
The other thing that I'm trying to work out and haven't found a solution to yet is so I've got Jose's model and I've got the original model and I've got Rafi's model and I've got, for example, OpenAI. and I can use all of them, and I can work out what's the R squared and what's the MSE and the MAE that they predict this data set, and I can also test it on other data sets. And then like the R squared, like when you put that in R, you will get let's say a p-value telling you, yes, this does correlate or it's not correlated. So they're all correlated. What I don't know is there a statistical test that will tell me that this model is significantly better than the other model and rule out the fact that it's just noise? Because you were mentioning that it was a bit of a like numbers jumping all over the place. And I don't
Part
know
of
if
it
there's,
was a lot of variance in how the human psychologists were actually evaluating the similarity between the questions as well.
there's a lot of variance, but then
which made it difficult.
yeah, there's also kind of consistent patterns where the LLMs get it wrong. And like the closest one that I notice is sleep. Everything to do with sleep is bunched together, like because there's just so much about sleep, and then the LLMs are trained on this whole, let's say, like space of every possible sentence, and then the psychology questionnaires are just this narrow segment of it. So it just all gets bunched together, and we don't have this great discriminative power when you're within that really narrow domain. And so I'm hoping it looks like your model and Rafi's model kind of addressed that a little bit better. I'm also kind of wondering about things like hyperparameters. Did you get time to play with that very much? Like, so learning rate and epochs, or was that you didn't get time to look at that?
Yeah, no, so I actually, right after I actually decided to, because the main objective was, I'm going to grab this data set and then I'm just going to fine tune the model on this using, cosine laws with L1 laws. It kind of like aligns with the objective that's meant for this competition. And it's kind of straightforward from there. But then if you wanted to kind of get an improvement over that, you kind of had to get a little bit more meticulous with the hyperparameters. So what I ended up doing was considering two more things on top of, let me check my, so I considered batch size, epochs, learning rate, and then I had two additional hyperparameters, which were freeze up to and dropout rate.
Yeah.
So the dropout rate actually was for both attention probabilities, not the actual kind of like, not the actual probabilities are actually calculated after the softmax operation in the attention mechanism, and in some hidden layer dropouts. And what's kind of weird is that I set this parameter to 0.2 to actually obtain this score, which means that it was for getting like 1/5 of like the information that I was actually trying to process. But other than that, it was the dropout rate and it was the freeze up to. And my logic for the freeze up to was, I'm just gonna freeze the embeddings. There's no use in kind of like fine tuning the embeddings. I would like them to keep kind of like their semantic meaning, right? And then I'm gonna freeze the first n layers of the sentence transformer model, because my hypothesis, right, was that the lower layers will be able to kind of process kind of like the local relationships between the words or the tokens, right? The vectors get enriched as you actually go through the whole like sentence transformer. But in later layers, you kind of focus on like higher level meanings and relationships and kind of like global relationships with other sentences, kind of like in the text. If you have like a big text, here it's only a sentence, so it's not that applicable.
So were you training just the last few layers, or you were training the entire model?
I was training the last few layers.
Yeah, okay.
So
Do you know, was
like,
it just like the last one layer? I need to check in your script and work out where that's defined. Was that, Jeremy, was that kind of the default defined in the script that you provided?
If he changed anything, for example, like the structure of the head, it'll probably be in the training script.
Oh, okay, we'll have to have a look at that. Yeah, because I know, like, obviously,
in the JSON file, it will be there as well.
Oh, it'll be in the JSON file as well. Oh, okay. Well, maybe can I share? I'm gonna see if I can share screen and show.
Somewhere.
No, yeah. Okay, no, actually, I think it doesn't work. All right. Yeah, I'll have a look at that. Oh, wait a second. No, yeah, I can't. Okay. Yeah, so I've got your script. Actually, your script is outputting all the details of the trainable parameters, so it's quite a few layers. I can see it in there. Yeah, okay, that's really interesting. I was also wondering, like, do you think that there's enough data, that enough data was provided, or do you think, is it unrealistic to train an LLM on such a, because it's only like a few thousand sentence pairs? Is that just unrealistically small?
Yeah, I was talking about it with Rafi, and we definitely kind of realized that, regardless of whether you actually switch to something else, another model, another architecture, whether you freeze stuff, whether you do anything else, we kind of don't think we actually would have managed to get to sub 20 unless we actually had more data. Because the problem was, and I was also talking with Alex Nikic,
Yeah.
I think
Yes.
his name is called. I think he was the third place.
Yeah, he was a third place. Yeah.
Yeah, and he was mentioning like, hey, like, just to kind of like give you a heads up, if you could try this, because I noticed that in the data set, there's always two sentences that will be rated differently. So he was proposing is, hey, you should try and basically grab these sentences and just combine their scores and take their mean, so that the model doesn't get confused whenever you're actually kind of training this. So by kind of also kind of reducing and taking all of the unique ones and just kind of reducing them to their mean, you also lose about 350 rows. So you end up with around 2,000 examples to kind of like skim over. And on top of that, another thing that I kind of thought about was, well, if we're missing training data, what if I just use like and I think it's somewhere around my script. It's kind of like an experiment. I was like, well, what if I paraphrase like the sentences, right? Because
data augmentation, or almost upsampling, augmented or synthetic training data.
Yeah, kind of like basically synthetic training data. And obviously you can vary the temperature to kind of like decide how like spontaneous it'll get or how variant the sentence would actually be. If you had a very small temperature, it's basically just changing one word or something, right? But if you kind of up this temperature to like 100%, then it's a totally different sentence. And I was kind of testing it, but and it looked to be performing well. But what I was kind of scared about was that, this paraphrasing model, even if I put like a certain temperature, I don't have the criteria to kind of say this is, still a valid sentence, and these two sentences will be scored as so by the psychologist, right? Because that's kind of like the problem. You're kind of basically mapping. I feel like you're kind of basically mapping what the psychologist interprets for the sentences. But if you're trying to if you're trying to do some kind of like data augmentation, right, or you're trying to create more synthetic data, you kind of have to have that criteria of the psychologist in mind. Because if you're kind of creating more data and you're kind of, wrongly labeling it, then I feel like the model is going to get a lot more confused. And it's going to kind of like moving the weights in a direction you don't want them to move, right? Whether it be because the paraphrasing model, actually did something weird, and then maybe the word was worded differently, but maybe the psychologist thinks like, hey, this actually changes the whole meaning of the sentence. So I actually wouldn't like, if I would actually rate it this instead of that, right? So I feel like there was a sorry.
Yeah, I was just wondering about would we avoid the problems of overfitting by training fewer parameters? So because I can see that it's more than one layer that you trained. Is it perhaps one option would be to cut down the number of parameters that you've trained, given the the small number of training examples?
Yeah, specific, like also very especially if you're trying to fine tune a model, because if you're trying to train the entire thing, then they're just going to be you're going to be doing very small tweaks to the entirety of the thing, and you're basically going to have no effect whatsoever. So you just want to focus, and that's by kind of like a general heuristic. This also kind of applies in like image processing, where you'll basically just kind of like fine tune specifically the last few layers, because you have like maybe like a ResNet 50, right? Because the ResNet 50 already is trained to actually do whatever it's actually supposed to do. And that, by how a convolutional neural network actually processes the images, it'll first focus on the edges, then it focuses on like the specific objects, or well, it just kind of builds up the image from the first few
Yeah.
layers to the end.
And you always need
So-
edge detection, and you always need circle detection, and so on. Yeah,
Exactly.
yeah. That's kind of my experience of fine tuning as well. Like where I learned to do it was like years ago in a company. We were taking the CNNs that people have put, like public CNNs that people use for the ImageNet challenge. So it's, got these 1,000 categories like, Husky, and Malamute, and then like, I don't know, like coffee cup and whatever, like all these objects. And we were making it work on faces. It's like trying to adapt that's general, make it work on faces. And so we locked every layer. It's got like, I think the Google net was the one we were working with in the end. It had like 26 layers, and we locked layers 1 to 25. And layer 26 was the only one that was free to kind of move around. And you can kind of chop it off and replace it. So I think you're doing something similar, although kind of with more layers in this case.
Like the smaller batch sizes and the dropout matter from, their regularizing effect
Yeah,
process.
I think so. Yeah.
And that also too, it's a small data set, so you kind of you wanted to counter overfitting because you're going to do
Yeah.
like 5 epochs, right? So that was also kind of like in place to kind of stop that.
Yeah. I was thinking maybe I was wondering if you had done a small number of epochs basically because of the overfitting issue as well to kind of avoid that. I mean, I can also, because I have other data sets to test it on. So that's one thing I've been kind of playing around with your model versus like OpenAI versus the original model, and checking how how they perform not just on this one, but we've got another data set which isn't psychologists marking things as being similar. It's the correlation when you run those surveys in a population. It's what's the correlation that people answer a particular question and then also answer another question. Like, let's say, so you ask them about, trouble sleeping, and then 10 questions later, you ask them about, do you feel anxious? And then those are unrelated, but maybe the people who answered 5 to trouble sleeping also tend to answer 5 to, do you feel anxious? And so there's a high correlation coefficient between the two. So we've got another data set that we can use, which is like a different task, but it's kind of related. And that's stuff where much more data is available. I was thinking,
Would it be useful to talk a bit about how the challenge data set was collected from the psychologists?
oh yeah, we should do. Oh, by the way, before I forget, like I forgot to introduce you and me. Like, do you want to introduce yourself and I can cut it in?
Or shall we do it at the end and then it's
Let's
easier
do
for you
it,
to splice
yeah.
the beginning?
Yeah, that's true. Yeah, I'll have to cut this part out anyway now.
It's
No
fine.
problem.
You'll probably want to put the whole thing down anyway.
Yeah. Okay, yeah, so it's what was it? Yeah, so how the data was collected. Gee, that's something I need to ask Owen. Like, so oh yeah, so okay, so the psychologists who were working on this project, which is Owen and Bettina. Owen's in Ulster University in Northern Ireland. He ran an online survey on a platform called Gorilla, and people were paid a small amount to answer these questions and to tag which questions they thought were similar. And I'm not sure what the qualification was that they had to have to take part in it, but it was manually gathered, and it was several hundred people that participated in the construction of the data set. So we made that data set for this project, and I mean this challenge, but we're doing a few other things with it as well. So it's kind of not a data set that's kind of floating around that we just took off the internet. A lot of work went into building it. And I think that's kind of often a challenge that you get in in kind of machine learning, where data sets that are constructed manually, that you go out of your way and you pay people to like tag or annotate, or like annotate images or annotate documents or whatever. Like you never get to these colossal scales that you need for some of these things like LLMs, because there's just, it's so incremental. And then on the other hand, you've got data that gets gathered by accident, like the data sets that Google have of people's Google searches, that just like they get that for free. And so because we're in that first category, we'll never get these huge data sets that we would ideally have. And I wonder if there's maybe from what you said about the size of the data set being a limiting factor, ideally, yeah, we would want to increase the size of that data set by a factor of 100. And then you can't do that by gathering the data the way that we did gather it. So yeah, what exactly, I don't know. I don't know what the answer is there. Maybe we need to think about if there's any way we can gather data for free. And one possibility might be kind of if we can get data from some kind of national healthcare system or health insurer or somewhere, that would, that might give us a bit more, a bit more of a larger data set.
Yeah, because even so, like, you still need good data,
Yeah.
right? Because then if you're kind of like sloppy, collecting data and then you're getting a lot of like wrong labels, then your model is basically just going to replicate that exactly. So I think it's a lot more better when you have something kind of like smaller that is kind of like well, labeled and well like kind of like organized and
Yes.
thought out. And if you massively scale out but just kind of let everything loose, and then just kind of grab people who are probably not kind of like qualified to kind of like put a rating on it, because then maybe the actual qualified person's criteria is not the same as the average
Yeah.
person's criteria, right? And so the kind of like the model gets confused because but overall, like you would think that something like, oh, do you feel on edge and I'm angry is actually, they're similar questions,
Yeah.
right? But I'm also kind of black boxing this because I know that there's probably a lot of questions there that might look similar, but they're probably not by the rating of psychologists. So I'm kind of reserving myself from saying I know that this works or I know that this doesn't,
Yeah.
because I don't know what like the actual criteria. I keep saying criteria, but it's like kind of like because everything depends on the criteria of the psychologist, because you're basically kind of transforming the space to kind of act according to that criteria, right? But if there's two conflicting criteria, then it's just kind of take the average of both of those, right? But it's not going to be totally aligned towards one. It's going to be aligned towards like kind of like in the middle, right? So you would want it to be kind of like fully aligned to one direction rather than the other.
Yes. Yeah. I think, yeah, there is obviously that trade-off. I'm wondering if it would make sense to use something like TSNE, or maybe not that, like maybe some kind of dimensionality reduction and get the whole thing reduced to like a smaller space. And then, like if you only had like 10 dimensions or something, then maybe you have far fewer parameters to play with at the lot, and you could just add maybe even not fine tune a model, but stick your own like processing at the end of an existing model, where you reduce it to kind of that small number of dimensions, because we have, if we have 2,000
potentially
training
reducing the head size.
Yeah, instead of reducing the head size, maybe sticking it on the end after the head. Yeah, or kind of because if we got 5,000, what was it? I can't remember. It was 2,000 training examples, wasn't it? So you can't have a 2,000 dimensional model. That's just, ridiculous. Like, could you cut it down to, I don't know, a 20-dimensional model or a 10-dimensional model? Then you have far fewer parameters, and then your model isn't going to go off and do any overfitting.
Probably depend on how you define your final layers.
Yeah. Yeah, so Rafi, we've just been talking with Jose about how he trained his model. Would you like to let us know how you found out about the challenge? Have you fine-tuned a large language model before? Is it the first time you're doing it?
Oh, yes, I would love to. So about how I found this challenge is I live in London. So there was this event at, I think there's some place where I went. It was an AI event. And the last bonus session was, I think it was from Benita or Bettina, whatever, I forgot her name. He's one of the organizer of the event, and she introduced me to it while she presented it. Like, this is the competition and we are hosting it. So if you feel like, please join. So then I went home, I saw it, and the one thing I should say is it was really the way it was, the way it was executed and the way the DOXA platforms, it was really easy, really convenient to submit and to get an answer on the leaderboards. That's one thing I should say, that because from my first submission, which was really quick, that motivated me to do some more changes and submit again to see where I lie in the leaderboards. So that was my first motivation. And the second was like, it was a week, just about a week for the deadline. I looked into the leaderboards and I saw Source was at the top as like from the start. So I just thought of making an effort to reduce the MAE. So what I did, my first approaches were to just use the MPNet base model and with fine-tuning the parameters and just arriving to a conclusion, which I did, but it did not take me to a position in the leaderboards lesser than 5. So I was like in position at 5, 6, or 7. But then I think the Hugging Face helped me a lot. I used the MTEB leaderboards, which has the number of models listed to the how they perform in the benchmarks.
Yeah,
So
I saw you experimented with a lot of different
Yeah.
base models, didn't you?
Yeah, so those models, first I chose the random model which were on top, but then I read about the benchmarks. What does that mean? So it was, I think, SDK 2017, which was contextually relevant to what we were doing. So I thought, so I sorted the models based on that benchmark, which was specific to the use case. I think it was false. So from that, I chose the model which was like which were like not the first, second, third, because they were really large models, and I cannot do that. So I chose the one which was small, convenient, easy to train, and which was easy for me to commit to DOXA platform. That was the approach I used. Then I chose model. The Snowflake performed better than all those models. Then I fine-tuned it, played with some parameters and stuff. And then that's it. I arrived at the lowest I could get was 20.566. I couldn't go beyond that. That was it.
And did you try playing with things like learning rate and dropout or any of those?
I did. I played with learning rates. I think I played with learning rates the most. I kind of don't remember exactly the learning rate number which I tried, but I tried a couple of them, and those were I think the learning rate was the reason I was actually getting. I was seeing the changes in the MAE and MAC. Even just changing the learning rate, that had a lot of effects, I would say.
How did you decide on the number of epochs? Because I can see you did 3 epochs, just like Jose did.
Yeah. So that took a lot of my time. There's not how I decided. It's like I just did. If you see the number of submission I made is like 25, 30. So I tried a lot of like 5, 10, 15. But what I saw is like those metrics which we tested. Pearson, and I noticed that whenever the metrics results before submission was in the range 0.68 to 0.78, it performed well on the leaderboards. But whenever the metrics were like 0.85 or 0.9, like really good, it did not perform well on the leaderboards.
So is that overfitting, do you think?
Yeah, it's completely overfitting because it was not able to generalize well in the unseen data set.
Okay.
That was my observation. I might be wrong, but any values which were like 0.68 to 0.78, if both the metrics were in that ranges, it really performed well on the leaderboards.
Okay. I have another question which I want to put to both Rafi and Jose. So if the challenge had been reopened, let's say if we were to reopen it today and you had unlimited time to improve your model, what would you do?
I should go first?
Yeah, if you like, yeah.
Yeah. So as I was discussing with I think it was Jeremy, just the deadline, when it was the deadline time, Jeremy Howard, you should all be very familiar with him. He released the modern BERT model, which
Yeah.
I was following by a couple of months. But it was the base model, like so there was not many embedded models at that time. So, but now, I think if you were to open the challenge again, I think I would experiment more with the modern BERT base model, which uses its architecture but fine-tuned for more specific cases, like somewhere related, contextually related to the psychological survey questions. That
Okay.
would, I think that I'll dedicate my time there.
Yeah. Thanks. So what about you, Jose?
Yeah, so I think if I had more time, I would definitely try and expand the training data.
Yeah.
Because I think, it's going to be proportional to the amount of data. Well, to actually improve the performance of any model, you need two things. You need complexity and you need data. And specifically for data, there's a caveat. It has to be good data. And I think if you have kind of like those two things combined, as per OpenAI's kind of neural scaling laws hypothesis, right? Then I think you can get a much more better performance on the. I would also like, I would experiment around with the paraphrasing model just to kind of try it out, see if it actually gives any results. Creating some more synthetic data, just kind of try it alongside of also manually created data. And I would definitely try some other architectures as well, because sentence transformers look to be like the most robust approach to this problem. But I'm a little bit worried whether the meaning of the sentence still gets fully kind of like encoded within one vector. Because from what I understand and from what I read, what happens is that to actually get this sentence, right, representation, what they end up doing is that instead of just kind of having all the tokens, they just smush it into one vector that just kind of encodes all of that meaning. And so obviously you kind of lose a lot of context from that, especially like from like word positions and embeddings, but I don't know, probably kind of like an exploratory thing, because I think, yeah, we could kind of use a sentence transformer again, but I think there may be some more novel approaches we can actually do to actually approach this.
Thanks. That's really interesting.
I just want to thank Jose and Rafi once again for taking part in the challenge, and shout out as well to Alex, who's also on the call. Thank you so much for taking part over the past couple of months, and hope to see you in future challenges as well, the parsing challenge and future ones we may run as well.
Thanks very much, everyone. Yeah, congratulations again. And thanks a lot for taking the time to talk us through what you did. It's really valuable.